looking at parallel and perpendicular lines. So parallel lines are important just because they don't intersect. We studied parallelograms a lot before I actually left. But if we're talking about like two cars going the same speed, that means they'll never run into each other, which could be a good thing, right? So that's the first thing about parallel lines, is that they don't run into each other because they're moving at the same rate. Now, the generic word we use for rate here is slope. So if two non-vertical lines are parallel, then they have the same slope, right? Or rate, speed, whatever we want to call it. So you can imagine two cars starting at two different places, going the exact same speed the whole time. Well, one will not get closer to the other at any point. They'll stay the same distance away from each other that way. And our other test today is perpendicular. You might remember that as a 90-degree angle. So the question is, how can we tell if two lines make a 90-degree angle? The main reason for this is what we just got finished doing, is that if we make 90-degree angles, we can then do trigonometry to find missing sides and lengths and things like that. But that trigonometry only works with 90-degree angles, so we're very concerned about if two lines are 90 degrees. I have trouble getting this to be right position. There we go. There we go. 90-degree angles. Now, there's a couple ways of doing it to see if there are two are 90-degree angles or not. Remember, 90-degree angles is what perpendicular means. So just throw that in the back of your mind there, 90-degree angle. There's two ways of figuring it out mathematically. Number one, or one way mathematically, the slopes multiply to -1. That's one way. So if you just multiply the slopes, they equal -1. Very mathematical. The more visual way of doing this is this. Then slopes are opposite, two things. Opposite reciprocals. You might recall reciprocals means just to flip a fraction. Opposite means one's positive, one's negative. Either one of these definitions will give you that answer, okay? And we use a little some notation here to make things easy. We have two lines, and in later classes, math classes, you'll have a lot of lines floating around. So there's a good practice we do is we just label them like line 1, line 2. So if I'm finding the slopes for these, later on I'll be writing those slopes down. I want to keep track of, well, which is the slope for which one. So I use this. I go M, the slope of the first line, and I write it right next to this, and the slope of this line. And I'll call this one M2, slope of the second line. It doesn't matter which one you call the first line, the second line. The fact is that we just have a label for it so we don't mix them up later. And then do the same thing we've been doing. Pick 2 points, any 2 points. Like here it's going to be up 3 to the right 1. That's just 3. All right, and then here I can pick any 2 points and go down 1, right 3. And we can practice using both of these slopes. So if the slopes are perpendicular, this is what will happen. M1 times M2 should equal -1 if they're perpendicular. Okay. If it equals any other number, then they're not a 90-degree angle. They don't make a 90-degree angle. So I can just test it out and say, well, my M1 is 3 times my second slope is -1/3. And the question is 3 times -1/3, does that equal -1? And of course, 3's cancel out, and yes, do have -1 equal to -1. Therefore, that's what 3 dots mean. Therefore, lines are perpendicular. And there is another definition down here. I said if they're opposite. Okay, so 3 is positive. The second slope is negative, so they are opposites. And if they're also reciprocals. So recall reciprocals, if I have 4/5, the reciprocal of 4/5 is 5/4. And the reciprocal, if I have 1 over 3, the reciprocal of that is 3 over 1, which of course 3 is 3 over 1. So that definition works as well. If you want to check to see if the signs are different, and if it's like basically a flip fraction, they will also multiply to -1, and those are perpendicular. So 2 ways of looking at it. So I want you to get used to this notation though here, where I'm writing M1, M2. If anything, that might be the only thing that's new. It's just a clearer way of writing your math to be absolutely certain. And I'll throw this out right now. Where to go? Find it. There it is. So if I go back to DudaMath, one of our favorite tools here, you might notice it right here. We have our slope formula that we practiced yesterday, the point slope that's on the back of your homework from last night. Right, those are there. And then right below that is, guess what? The test for the perpendicular. So if you see that M1 times M2, that's testing to see if it's perpendicular. So you could just punch in, your 3 for your first slope, and then your second slope, put in -1/3, and then multiply these all together. And if you get the same thing on both sides, then yes, they are perpendicular. That's all that is. Okay, so all these right here we're using right now. These are all for linear equations, these 5. 1, 2, 3, 4, 5, yeah. So DudaMath is always a good website, good resource. And likewise, I'll go back to parallel over here. These are a little bit easier because they're just the same slope. So if I can just label these and find, okay, find the slopes for both. So the slope for this first line is 2. And then do the same thing over here. Slope for the second one is also 2. And we just say M1 equals M2. They're equal to each other. Therefore, the lines are parallel. There we go. So just the notation here, using M1 and M2 just to designate the two different lines. Obviously with parallel, it doesn't matter what you call which one because they're the same. With perpendicular, someone else could call the top one M2 and the bottom one M1. It's not that important right now, but just to get used to the notation is a good thing. All right, so using those two definitions, let's just practice seeing if it's parallel, perpendicular, neither. So of course, lines don't have to be one or the other. They could be neither. So I'll do a few, then you can do the next 3. So I'll look at the first one. Say M1 up here. There we go. M1 is a slope of 2 over 1, or just 2. And then M2, second slope, is also 2 over 1. So I could just say M1 down here equals M2. Therefore, they're parallel. Over here on the second one, call this one my M1 first slope, which is what, 3 over 1? Slope is 3. Is that correct? Is that correct? Absolutely not. It's negative 3. So you can mess up on these. Once again, negatives, if you make a mistake, will be the mistake. So careful. From the very beginning, when I look at this, I already told myself the answer should be negative because it's going down. So make sure you get in the habit of doing that yourself. Like, okay, this answer will be negative because it's going down. And then when you're writing your answer, you will less likely to forget that sign. Same thing here. I know my answer is positive, so it's going to go up 1 over 3. Goes positive 1/3. So down below, I'm suspecting this is perpendicular. Obviously, they're not parallel, so I'm not going to bother seeing, well, these two numbers equal? Clearly, they're not. But I want to check to see if they're perpendicular, so I'm going to take my two slopes in either order and see if they equal negative 1 when I multiply them. So you're checking to see, well, does negative 3 times positive 1/3 equal 1 or negative 1? Yep, negative 1 is the definition. So clearly 3 cancels out with 3, and we're left with negative 1. So yes. Therefore, perpendicular. Now you might remember from first semester, we have a symbol for perpendicular. You might like this better. And you just write M1 is perpendicular to M2. So if you like using this symbol right here, the upside down capital T, basically it's two perpendicular lines. If you want to use that notation, you can instead of writing out the word perpendicular. So therefore, first slope is perpendicular to the second slope. All right, there you go. All right, so there's two, one parallel, one perpendicular. Go ahead and do the next three in a similar fashion, writing out some conclusion at the very end, just like I am. Okay, so don't just do the first part and say, and then write one word. Put M2 is equal to M1, and if you think they're perpendicular, actually show the multiplication where you get negative 1 on both sides, or you don't get negative 1 on both sides. So you need the proof here. So I'm not showing you this for you to just skip it and say, I think it's this. Actually write it out and verify, okay? So I'll give you a few minutes to do that right now. So you should have something of this nature, right? For the first one, for the middle one here, clearly these are not going to be parallel, right? They intersect with each other, so I'm not going to bother to compare them to see if they're equal. However, this kind of looks like it could be a 90-degree angle. Actually, it looks very much like a 90-degree angle. However, upon inspection, when I multiply these, negative 3 over 2 times 3/4 does not equal negative 1. So therefore, it's neither. No G. Neither. And then on number 4 here, the fourth one, when I compare them, one's 4 over 4, one's which is equal to 1. The other one is 2/3, so these are neither equal, so they're not parallel. And these don't multiply to negative 1 either. So these are also neither. And then finally, when you get to over here, we see that the two slopes are parallel because those two slopes are equal, negative 2 and negative 2. Therefore, they're parallel. We've got plenty of examples here of parallel, perpendicular, and neither. And these two are very good examples of how close, this looks like to be a 90-degree angle, just like this. However, this one is perpendicular, and this one is not, even though they both look like they could be perpendicular. So watch out for the imposters. Okay. And then lastly, let's get to some equation writing. Okay. So the next thing is, let's write some equations that are parallel and perpendicular. So the parallels, of course, are going to be same slopes. Perpendicular slopes, when we get down here, are not going to be the same. They're going to be a different number. So, of course, this relies on us finding the slope and then making an equation. This is where the point slope formula is going to come in, and that's what we used on the back side of the homework yesterday. So for this, when you're doing parallel, they're going to be the same. And all these steps are the same except for step 2 between them. That's going to be slope. On the second one, the slope of the perpendicular line will not be the same. It will be an opposite reciprocal. Okay? Just so you know if you're working ahead. So my M1, because it gives it to me here, for parallel, is just negative 1/3. So the slope of the line parallel is also negative 1/3. So when these are parallel, of course, M1 equals M2. Right, that's M1, this is the M2, they're equal to each other. So now find the equation. If you have a slope of negative 1/3 that goes through up this point, right? This is how you know you're supposed to use the point slope formula, because they give you a point, which is an x and a y, and the slope. This is the x, of course, that's the y. And we're just plugging that into that formula. So we got y minus y1 equals the slope times x minus x1. So if I just substitute everything in carefully, the y1, let's see here, we'll have green. My y is equal to 5. And the slope, negative 1/3. And the x is 9. And that's the equation of the line. Now what you can do, another tool that we haven't used in a while, is Desmos. So what you could do is, if you're going to check, is you can type in your answer, which is y minus 5, just in that same format, equals -1 over 3, x minus 9. All right? And also type in the coordinate that it's supposed to go through. So this is supposed to go through what it says up here, 9, 5. So I'm going to type that in parentheses, 9, 5. And if everything went correct, you can see that the line actually goes through the point, and you can zoom in and actually show, like, yeah, down 1, right 3. It does have a slope of -1/3. So if the line actually goes through the point that you're supposed to, you know you have the correct equation. So you can use Desmos to check anything that's graphing. And again, between Duda and Desmos, if I go over here, I do have a point slope formula right there where I can plug in y1 and the slope and x1 as well. So these are going to be very handy for checking your work. Okay, and that's it. That's all we're going to do. That's the equation of the new line. I'm not going to have you find the y-intercept, so don't worry about step 3 right now. Okay, so a few of these. Identify the slope. The parallel slope, of course, for here will be the same. It needs to go through -1, 2. M is always slope, yep. And just for fun, to show you how I'd use this, I can say y1 equals 2. M equals 5. x1 equals -1. Now notice what happens. Notice how I get minus and -1. The formula has a negative or a minus, and so does the number. So when it simplifies, of course, it becomes x plus 1. So that would be the final point slope formula format. Y minus 2 equals 5 times x plus 1. So the formula has a subtraction, so does this. That's why it turns out to be positive right here. So the signs are always different, right? This is a +2, in here it's minus. This is a -1, and here it's positive. So the signs will always be the opposite. Now, if we wanted to find out the y-intercept, just so you know, I'd have to put this in slope-intercept form. And I could do that here. If I just click and drag and distribute the 5, and then move the 2 over, now it's in slope-intercept form, and the y-intercept is 7. So this is point slope formula, but if you distribute and then move the number over, that's what you did last night, slope-intercept formula. So it's two ways of writing the same line. Okay. All right, one more, and this is different because it doesn't have it in slope-intercept form yet. So we usually look in front of the x to see what the slope is, right? So I looked at this and said, well, where's the x? Okay, the slope is 5. However, before you do that, you have to make sure it's in y equals. So if you look over here and say, well, what's in front of the x? You say it's 3. That's not the slope because it's not in y equals format yet. The y has to be by itself. So in order to get this all by itself on the left-hand side, the 3x needs to go. So since it's positive 3x, I'm going to subtract 3x. And then pretty quickly you determine that the slope is, instead of 3, it's now -3. So you might remember doing this back in the day. So my slope is really, of this line, is -3. So my second slope is also going to be -3 because it's parallel. And then it needs to go through 9, -6. Write out the point slope form for this real fast. So take these numbers and plug it in just like I did on this one, watching your negatives and making sure those are done correctly. I'll give you a second to do that, just to make sure you got this, and then we'll do perpendicular and be finished. So the slope is pretty straightforward. It's -3. Okay. And then we should have, let's see, the first one here is 9, right? And 6. Is that correct? No. What's wrong? Yeah, so it's kind of a common error that, well, the first number is 9, so the first number is 9. Not true. First number is right here, y. So it's 6 and 9. Look good?
Wouldn't it be +6?
Yes, it's not good. It's +6. It's -6, so it's +6. So a lot of little details to mess up on. They're all related to negatives or just switching x and y. So just be careful on those 2 points. And you can always double check it using Desmos. If I plug my equation in with 9, -6 and my line doesn't go through 9, -6, my line's wrong. So you won't have to finish this homework wondering, well, am I getting this right? If you're checking your work, it'll be fine. All right, lastly, perpendicular, and we'll be done. So this is the same as what we just did. Consider we just did a warm-up. This is in y equals, so I know to look for the x to find the slope, which is 4. So my first slope is 4. The second slope is not 4. That's only for parallel. This is perpendicular, right? These are 90-degree angles, no longer parallel. So what is the line that's parallel to 4 that we learned from over here? Perpendicular to 4. So we have to use this process. If it's 3/1, perpendicular is -1/3. So this one is not 3/1, but it's 4/1. So what's the line perpendicular? Well, we can use the other definition. Well, this one's positive, so it's going to be the opposite. It's going to be negative. This is 4/1. The reciprocal is 1/4. So you can see it's not the same as parallel, where I just said, oh, these two are the same. -1/3, -1/3. It's not the case here. If this is 4, this has to be -1/4. So now I can write my equation with my perpendicular slope of -1/4 going through 4, 1. And from there, it's the same process. Y minus y1 equals the slope x minus x1 that's it. So what I can do to check my work here is I can type in y equals 4x minus 2, original equation. And then my answer, right here, it's got on the bottom here, y minus 1 equals negative 1/4 x minus 4. And then my coordinate, 4, 1. So I can do everything and check everything. So number 1, do these two lines look like they're perpendicular? Yes, they form a 90-degree angle. Does it go through my coordinate that I wanted? 4, 1? Yes, it does. So you're looking at two things here. It has to make a 90-degree angle and go through the point. If it doesn't do both, that would mean your answer is incorrect in one or more ways. So I put in the original equation, the equation I got, along with the point it should be going through, and check the graph visually to make sure it looks correct. So very, very doable to check these as you go along just to make sure. Okay. All right. Just one more. Let's just practice doing this. So this slope, it's in y equals form, is 2/5. What's the perpendicular slope to 2/5? What is it? Negative 5/2. Now if you want to, go ahead and try to check it on Desmos just so you know how to do that. So put in y equals 2/5x plus 3. Put in your coordinate, and then whatever equation you got, and see if it works. So if I'm doing that here, I put in y equals 2/5x plus 3. I put in negative 6, negative 8. Maybe take a look at this, zoom in. Okay, way down there. So I can see, here's my original line, and I'm trying to get a line that goes through this point and makes a 90-degree angle with this line. It has to do both. So your next line should be an equation that does that. So if I did something like this, and I messed up on some negatives, I'd look at this and say, no, it's not going through the point it should be. It should be going through negative 6, negative 8. My equation, if I did it this way, is not working, and you'd keep changing or trying to fix something until it worked. So what's the equation that you come up with on here? And if you're not sure, you have this other tool. And you could say, well, y1 is negative 8. And the slope is negative 5/2. And the x is negative 6. And you can see you get 2 of those double negatives. And that's the mistake I was having on my Desmos. They should be y plus 8, and it should be x plus 6. So if I go over here and put plus 8 and plus 6, and then also fix my slope, because it's not 2/5, it's 5/2, because it's still not perpendicular. It's going through my point, but it's not perpendicular. So if I change this to 5/2, There you go. Beautiful. It's now going through my point, and these are a 90-degree angle. So I've used both Dudemath and Desmos to check my answers, and I know that must be the right equation. Y plus 8 equals negative 5 over 2 x plus 6. So you have the ability, like I said, if you came in today with your homework kind of not done, you don't even know, you weren't ready for the quiz, you have the tools at your fingertips, right? Use them and you'll not be lost, confused on any of them. You'll have 100% and you'll know exactly that for sure. And you'll do very well in the quiz tomorrow morning. So be ready for that and use these tools and you'll be okay. Tutoring today after school in here and in the library. Okay? See you tomorrow.